Okay, there we go. Now it's working. All right, so C++ features makes it better. Um, in C++11, C++14, it's basically the year. But if you want to use some of these features, you have to compile it specially like that with the tag std equals C++ and then whatever version you want to do. So keep in mind if you're using these in like homework assignments or something, professor will probably not do that unless you ask them and they agree to it. So do keep that in mind. But for projects and stuff, it works just fine. Um, so the first thing is vectors. And all of these we have it'll tell you what you have to include up at the top, and then if it's in C++11, it says so. But basically, vectors are dynamically sized arrays, so you don't have to specify how big the array will be or like have a variable, and then that can kind of mess things up. But you can still access them with square brackets like you would a regular array. And then there are methods to like get the front and the back and add stuff to it and remove things. Um, so first we have our include the vector, and then you declare it like this. If you do using namespace std, you can get rid of that std:::. Generally, when doing C++ on like a real program, you probably don't want to use using std. You want to use it like this, but for assignments and stuff, it works out because it's way easier. But you'll declare it like that. In those angle brackets is whichever type you want the vector to be of. So if you wanted it to be like a vector of strings or a vector of vectors, you could do like a vector vector int, and that'd be a vector of ints. And then this push back is adding 1, 2, and 3 to the back of the vector. And then you can access it like this. So you have back gets you the back of it. Then v.front would be the front of the vector. You can use square braces, that would get you 2, or you could do v square braces 2 and you would get 3. Pop back, it removes it from the back, and I think it also returns whatever you removed. I'm not sure on that one, but it does in other languages, so it might do it in this too. And then v.clear erases it. So this can be super useful, obviously, when you have no idea how much data you have to store. And then you just need the array to change a whole lot. And then strings. So in C, strings are just character arrays. That's how you work with them. That's how they're used. But in C++, you can include them. They're like a class, but basically you use it similar to normal data type. So you can work with them as a string type instead of needing to declare like a 50 character array, and then if the string is too long, it breaks. And then similarly, there are methods so that you can work with it easier. So you can just get the length of it. That is 1. Oh, it looks like I missed a new line there. So you have to include your string here. This is supposed to be on a new line. It includes setting our string to be hello world. So if we do push back, I can add an exclamation point to it. You can do those pluses. That adds a bunch of things to the end of it too. And then you can access the front and back similar to that vector, and it gets you the thing in the front and the back of the string. You can get the length of it, and you can still access it as s square brackets 1, and you would get an e. So maps are a way to store data. So you would have the key and then the value at that key. There's 2 different ones. There's the regular map, which sorts it by the key, and then there's an unordered map, which just puts it in whichever order you put it in. So the key, you can do integers, but you could also do like strings or booleans, I guess, if you wanted to. That wouldn't really work out very well, but you could. And this could be used so that, say you're storing like a person's ID and then their name. You could put their ID as the key, their name as the value, and then it allows an easy way to consolidate similar data like that. And then the type for the first type has to be hashable. So you can't really use this if you like custom defined a class, because C++ doesn't really know how to hash your own class. But then the second type, it can be whatever you want. So here's an example. We have our map which is the key will be strings and the value will be integers, and our map is M. So you can insert it. Maps are kind of like vectors of pairs, like conceptually. A pair is just a thing that has two values, basically like an x and a y, like on a coordinate plane in math, but it doesn't have to be only integers. So when you add things to a map, you have to use this make pair thing. So then this stores, so like our key A will have a value of 1, and then you can access it M at the key of A, and it will return 1 for you. I missed a couple new lines, it looks like. Bummer. So this is how you declare this very long thing. You'd have a map that's a pair of ints. That's kind of basically what it is. And then similar here, make pair 1, 1, add 1. Then that would do stuff, I guess. Smart pointers. These are ways to make pointers less dangerous to utilize. You have to use C++11 there, but it makes it so that you don't have to worry as much about new and delete, like allocating and deallocation. It can try to help fix memory leaks, so that if you accidentally forget to delete a pointer in a function, that pointer doesn't stay there. And there's 3 types. There's a shared, a unique, and a weak pointer. We're not really going to mention weak pointers. They're not as useful. But shared and unique are very similar. There's just some slight differences. So here we're declaring our unique pointer of a vector. And it's going to be making a unique pointer there of a vector. But then we access it. Notice instead of doing dot, since v is a pointer, we use the arrow notation to use the methods and stuff. And then after this theoretical function ends, the vector will it'll be closed, so we don't, or deleted, so we don't have to worry about deleting it. It does that all by itself. So unique pointers can only have one thing mutable referencing it. It doesn't have like a way to copy. So if you tried to set another unique pointer equal to u, so you could have 2 different ways to reference it, that doesn't work. If you wanted to do that, you would use a shared pointer. So when you use a shared pointer, C++ keeps track of how many things are referencing that pointer, and then when that count hits 0, it gets deallocated. Lambdas are anonymous functions, which would be a function that doesn't have a name and you don't have to like declare it usually at the top of your program where you declare functions. It allows you so that you can use the function, kind of pass it along like a variable and use it in that sense. This is very similar to, if you remember in JavaScript when we were talking about some of those functions where you can just slap a function in the middle of a different function to do stuff on it. It's basically the same thing as that. So here we have this function square. Notice how we're declaring that more like a variable instead of like a regular function. And then, so this one, it just returns squaring 2. So we get 4. So the different ways is the square brackets, it captures variables kind of in the surrounding so that you can just use it from there instead of needing to pass it as the parameter. Then parentheses is the normal, and then square brackets is also normally how you use it. So again, here we have our function of adding 2, and notice how in the square brackets we put x, it knows what x is as 2. So then when you pass in add 3, it knows that you're going to be adding 3 to 2. So if we put in add and then 4, we'd get 6. You don't have to redeclare that it's going to be getting 2 because it's stored in that variable location, technically, kind of. Iterators is basically a pointer. I mean, you don't use it like a pointer, but to a specific spot in a collection, which I'm using to refer to usually vectors and maps and also arrays. Just to shorten up these slides. So you can use it if you want a for loop over like a map or a vector. You can use iterators instead of your standard like for loop with int I equals 0, I++, stuff like that. So that's how you, there's a quick thing there. That's how you can declare a vector without doing pushback a whole bunch of times, the same way you do it with an array. And then if you want to declare an iterator for a type, you do take the type of your vector. So we have a vector int, and then you do : iterator to tell it that you want an iterator for that type. So it's getting an iterator for a vector of integers. And then .begin gets us the front of it. And then if we deallocate it there, we would get 1 because that is the front of it. So if you notice, these types can get very long, especially when working with maps and pairs or vectors of maps, because that's a thing you do sometimes, which is where auto comes in. It can allow C++ and the compiler kind of figure out what that variable type will be. You don't really want to use it in the same sense where like just changing types willy-nilly and go from a string to an int to a float. Like that's not its purpose. It's useful for an example like this where this type all by itself is basically about how long most lines of code are, and then you have to like declare it and everything. So you can make it short there. So here we have some more stuff. We have our int and our float, and then this vector of an integer. But what we can do with it instead is we can set this auto int equals points.begin, and then it knows that this is going to be a iterator for the points, so that it can easily declare. We don't have to do map of int and stuff. It makes it way faster to do it like that. Then what was the thing up there? Yeah, so notice on the bottom, you don't really do it like that. You don't want to like just say AutoX and then set it a type later. That's more how you would do it in a looser type language like JavaScript. But if you do it like this, it'll be fine, because sometimes this square function might return floats, or except not if it's an integer passing, but it can. So sometimes functions though you do have, it might return a different type of thing, so that you can use auto in case it might not be an int one time, depending on your function. Then we have for each loops. These are similar to regular for loops, but it's an easier syntax when you're trying to loop over like a vector or a map instead of doing the longer for syntax. So again, we're going to be defining our vector, and then right here, assuming you can see that highlighting, we are declaring it as auto v. You could also put int there because v will be a type of, it will be an int. And then values is what we're going to be looping over. So for everything in our values vector, we are going to be printing out that item. If the input gets super long, you can add this little ampersand dealio here. It uses the reference instead, makes it faster, which is good because speed is important usually. So then the next things we're going to be talking about is the algorithm header. It contains a bunch of algorithms that people already know they exist, like sorting or finding things, and they've been optimized about as well as they can be, so you don't have to like write a bubble sort, which is not a very great sort. So it makes writing your programs easier because you don't have to rewrite sorts every time you want to sort. I figured I should put this in. If you get an assignment that says sort this array, don't just do include algorithm sort array. That won't count. You'll probably fail that assignment. But depending on the professor, if you have an assignment where you need sorted data, but learning a sort algorithm isn't the point, they may let you use sort on it, so you don't have to do it again. So we'll leave that right into sort. Usually you'll use this on vectors, but you could use it on an array if you had to. It defaults to ascending order, but you can change this if you use a lambda or a regular function. You don't have to put it in lambda form. So here we can just define our vector, even though it is already sorted, but we can sort from the beginning and the end. It tells it, it'll sort it, and then we get a sorted vector. Find, we can find things in it, basically searching. And then it gives you an iterator to the thing. if it finds it. If it doesn't find it, it returns an iterator to the end of, say, the vector. So then you can check if the function equals iterator or your like map.end, then you know it wasn't found and you can return like thing not found. So very similar syntax. You can just do this. You'll find the thing in there. 3 is what we're trying to locate. So it will return an iterator to the third position in the vector, which isn't the same as, I mean, it's kind of like, it's the third position. Yeah, that was a bad sentence. So then there's any, all, and none of. There are 3 different functions, but they all basically do like operate along the same premise. You need C++11 here, but what it does is you provide it a condition, and it will return true or false based off of if any of the things match that condition, if all of them do it, or if none of them do it. So up at the top, I just have this function is3. It checks if the thing is 3. And then we have our vector of 1, 2, 3, 4, 5. So the first one for any of, it returns true because 3 is equal to 3. So since at least one thing in the collection equals 3, it will return true. Then the bottom 2 both return false. All of returns false because not everything in it is 3, and none of returns false because one of the things is 3. And then for each, this is different than the for each loops that I just talked about earlier. With this for each, you can loop over, like say, a vector and do a different thing on each vector. So say you needed to like print everything in it, but you didn't want to use a for each loop or something for some reason, you could do that. Usually you use it for a more like a different thing, but so you can declare a vector again, and then for each, we give it the beginning and the end of our vector. And then here we're defining our lambda. In this case, we're just doing c.out. And in those any of, none of, we just put it in a function to make the slide shorter. You can put a lambda there too. But here we're just printing out x, but you could do a whole bunch of other stuff. But this can make it a bit nicer code when you need to do a bunch of stuff, or something simple like this. You don't have to write out a whole for loop just to print your vector. You can just put it in one nice line that's pretty self-explanatory. So that's the end. I feel like I talked really fast, but any questions? All right, well, remember everybody, if you want to do ICPC, sign up. If you want the shirt, you have to sign up by tomorrow. Otherwise, you have, I think, like a month to sign up. But until then, as long as there's still no questions, I guess everybody have a good night and do your homework.